first opportunity I have to expand and perhaps repeat what I say on the ship. You were actually privileged. You are the first audience I've been telling the whole, almost the complete story behind Ageloc. It is about not just taking care of signs and symptoms of aging. Our approach is really based on the fact that with our recent discoveries, we are now able, for the first time in anti-aging supplements or in skincare, that we can actually address or attack sources of aging. That is really our key, and that is perhaps our defining or differentiation feature in our anti-aging approach relative to all the other companies. It comes under this umbrella. When you think and when you talk about Ageloc, it's not just about a single product. It is about a new approach. It is about the brave new world of skincare and supplements. This is for once a company has been able to assess or to aggregate all the recent scientific evidence and all the studies that have been conducted over the last 40 to 50 years into a whole of new approach to making anti-aging products. That's really what Ageloc is. It is an idea that we have developed very much similar to what the Internet is. Internet originally was developed not in terms of the physical entity. It was developed as a big idea. And the browser, if you will, the Safari or the Explorer that you use to gain access into the Internet is what we have also included in our Ageloc. We have created an aging or anti-aging browser to look into these ultimate sources of aging. Now, there are thousands and thousands of these sources, so-called, related to all kinds of things in the body. Now, in order to make sense of what we are learning in the body, we also have created, together with our aging browser, what we would call an aging Google. We are now able to make sense of all the scientific evidence that we have been learning over the last 50 years and be able to relate that to aging. In 1952, James Watson, an American from Chicago, worked together with Francis Crick up in Cambridge. And they had been wondering exactly what is the nature, all the chemical nature of this so-called DNA. Everybody at that time, 60 years ago, were very interested in defining the structure of DNA. These two folks managed to do that. They got the Nobel Prize from it. This DNA was the beginning of the biological revolution. This started our ability to look really deep into different types of biological events or biological pathologies in the body. So remember, this DNA is very, very important. It is, in fact, a molecule of life. That is an original picture of what Watson and Crick worked out. I suspect you can probably see that still up there in Cambridge. But for all intents and purposes, you look at it, it is a double helix. It's a wonderful structure created by nature to contain all the genetic information that makes up your body. Genes regulate everything that happens inside your body in every tissue. There are no other things more fundamental in the body or in biology than the gene. Everything starts from the genes. If that is so, it is important to work out how many genes do we have in our body. What exactly comprises the human genome? Because the human genome is the book of life. What exactly, how many words are there in the book of life? In 2003, they worked out through the cooperation of 6 countries in 20 labs involving hundreds of scientists that there are roughly around 25,000 genes in the body that tell the body what to do. Again, 25,000 genes. It's almost like saying you have 25,000 words in the book of life. That's what those words, when they're put together in the proper order to form a sentence, that's how the body is written. So you can imagine, DNA, it took what, 1952 to 2003, that's slightly less than 50 years old, 50 years, but it took that long to figure out that we have 25,000 genes in our body. Now, we can begin the hunt. Now we know where to look for these so-called ultimate sources of aging. Because, like I mentioned, you can't go deeper or more fundamental than a gene. And by the way, it costs more than $3 billion to complete this project. So, this is what we're going to do to try and answer this question. 25,000 genes. How are we going to read that book? I think rather than going into all the science, what we have discovered in new skin is the gene Rosetta Stone. Again, if you go up here a few blocks towards Russell Square and enter the British Museum, you will see the Rosetta Stone. And what the original Rosetta Stone was all about, and why it was such an incredible find in archaeology, is because 3 languages were written on the Rosetta Stone. The first language was the hieroglyphics, the second one was slightly modern Egyptian, and the third one was Greek. Without the Rosetta Stone, we would still have not been able to read the hieroglyphics and what the ancient pharaohs were trying to tell us, or what they were doing 5,000 years ago. That is what the Rosetta Stone was all about. To make all the scholars, and for all of us, when we visit the pyramids, we know what was written, or what is written on those pyramids. They're not just pictograms. They are actually come together to form the ancient hieroglyphic language. When you think along those lines, what we are saying is, the 25,000 genes are like hieroglyphics. Nobody can read them. Everybody is going through each and every one of those genes and trying to decipher what they mean. For once, together with our collaborators, we have developed the Rosetta Stone to read those genes. We have used the most recent discoveries and aggregate all these discoveries together to be able to figure out where the aging genes are. We don't have to go hunting and browsing every single one of those 25 genes. We have, in other words, created an index to the book of life.